Welcome to the lecture on Advanced Calculus and Numerical Methods. In my previous lecture, I discussed about the solution of non-homogeneous partial differential equations by using direct integration method. In this lecture, I am going to discuss briefly about the solution of homogeneous partial differential equations with respect to one independent variable. So we'll see how to solve the homogeneous partial differential equations with respect to one independent variable. The first step is we have to convert the partial differential equations in terms of ordinary differential equations to obtain the solution of the homogeneous differential equations. So after converting the PDE into ordinary differential equations, we have to make auxiliary equations to find the root of the given differential equation. So after finding the roots, we have to make a complementary functions. So we have to represent the constants of the solutions in terms of arbitrary functions of other independent variable, giving which gives a solution of the partial differential equations there. So we'll see how to solve the problems now. The first problem, solve dou square z by dou x square minus z is equal to 0 given z is equal to cos y, dou z by dou x is equal to sin y when x is equal to 0. So given dou square z by dou x square minus z is equal to 0, I will call it as equation number 1. So I'm going to assume the equation 1 in terms of ordinary differential equations. So converting partial in terms of ordinary equations, that is d square z by dx square minus z is equal to 0. So it is an homogeneous ordinary differential equations, and we know how to solve the homogeneous ordinary differential equations. So convert the equation in terms of auxiliary equation. So first I'm going to replace the capital D is equal to d by dx. So I'll get the equation like d square minus 1 into z is equal to 0. I'm going to convert this equation as an auxiliary equation by replacing d is equal to m. So I got m square minus 1 is equal to 0. So roots of the equation will be m is equal to plus or minus 1. So the complementary function will be z is equal to c1 e power x plus c2 e power minus x is a solution of ordinary differential equations. But I want a solution of partial differential equation, so I'm going to convert this constant in terms of arbitrary function in terms of other independent variable. Say for example, now the solution contains the independent variable x, so the constant should be in terms of the y variable. So like I'm going to represent the solution like z is equal to f of y e power x plus g of y e power minus x. So call this one as equation number 2. So now to find the constants, these two constants, since the initial conditions has given like dou z by dou x is equal to sin y when x is equal to 0 and z is equal to cos y when x is equal to 0. So to find the constant we have to use this condition. So in the first step we have to estimate the value of dou z by dou x from the given equation. So I'm going to differentiate the equation with respect to x. So I will get since f of y and g of y is a constant, I'm keeping as it is. Differentiating e power x, it will be e power x only. Differentiating e power minus x will get minus of e power minus x. So now I'm going to replace x equal to 0 in the equation number 2 and 3. So if I replace x is equal to 0 and replacing z is equal to cos y and dou z by dou x is equal to sin y along with x is equal to 0, I got the equations like this. So from this equation, when x is equal to 0, z is equal to cos y, I got the equation like cos y is equal to f of y plus g of y. In this one, if I replace x is equal to 0 and dou z by dou x is equal to sin y, so we'll get sin y is equal to f of y minus g of y. So on solving these two equations, I will get the equation like 2 times of f of y is equal to cos y plus sin y. Or f of y is equal to cos y plus sin y by 2. So once we got f of y, we can easily estimate the value of g of y. So g of y will be equal to cos y minus sin y divided by 2. So I'm going to replace both the values of f of y and g of y in the equation number 2. So I will get z is equal to e power x by 2 cos y plus sin y plus e power x minus x by 2 cos y minus sin y. So from this equation and this equation, I'm taking cos y common factor. So remaining will be, I will get e power x plus e power minus x by 2. Same thing here also, I'm taking sin y common factor. Remaining will be e power x minus e power minus x by 2. So it will be equal to cos y into cos hyperbolic x plus sin y into sin hyperbolic x is the required solution for the given partial differential equation. One more example, solve dou square z by dou y square minus 4 into dou z by dou y plus 4z is equal to 0. So given z is equal to 0, dou z by dou y is equal to e power x when y is equal to 0. So the given equation is with respect to the independent variable y. So we'll see how to solve this. So as I told that, first we have to convert the partial differential equations in terms of ordinary differential equation. So we'll see how to solve the equation now. So I'm taking the dou square z by dou y square minus 4 into dou z by dou y plus 4z is equal to 0. Call it as equation number 1. So assuming 1 as in terms of ordinary differential equation, so I will get d square z by dy square minus 4 times of dz by dy plus 4z is equal to 0. By replacing d by dy is equal to capital D, so I will get d square minus 4d plus 4 into z is equal to 0. By converting an auxiliary equation, so I will get m square minus 4m plus 4 is equal to 0. On simplifying this auxiliary equation, so I will get the roots like m is equal to 2 comma 2. The solution of the ordinary differential equation will be equal to z is equal to c1 plus c2y into e power 2y. So now I want to estimate the value of the partial differential equation. So by replacing the constants c1 and c2 in terms of f of x and g of x. So now the solution of the partial differential equation will be by replacing c1 is equal to f of x into e power 2y plus y into c2 as g of x into e power 2y. So this is a solution for the partial differential equations. So now we have to estimate the constants f of x and g of x from the given initial conditions. The conditions are given like z is equal to 0, dou z by dou y is equal to e power x when y is equal to 0. So first let me estimate the value of dou z by dou y. So differentiating this equation with respect to y. So treating x constant, we'll see what will get it. So I got the equation like dou z by dou y is equal to keeping f of x as it is, differentiating e power 2y, I got 2 times of e power 2y plus keeping g of x as it is. Since here product rule I'm applying here, first I'm keeping y as it is, differentiating e power 2y, I got 2 times of e power 2y plus keeping g of x e power 2y as it is, differentiating y, I got 1. Call it as equation number 3. So now if I replace y is equal to 0 and z is equal to 0 in the equation number 2, I got the value f of x is equal to 0. Again I'm replacing y is equal to 0, dou z by dou y is equal to e power x along with f of x is equal to 0 in the equation number 3. I got the value like g of x is equal to e power x. So replacing this condition in this equation, the solution will be like we'll get z is equal to y into e power x 2y. So this is a required solution for the partial differential equation. So next problem, solve dou cube u by dou t cube plus 4 times of dou u by dou t is equal to 0. Given u is equal to 0, dou u by dou t is equal to 0, dou square u by dou t square is equal to 4 when t is equal to 0. So take the given equation first. So assume the given partial differential equation as an ordinary differential equation. So we'll get d cube u by dt cube plus 4 times of du by dt is equal to 0, and finding the roots for the given equation by making it an auxiliary equation. So I will get m cube plus 4m is equal to 0. So m will be equal to 0, m will be equal to plus or minus 2, I will get it. So now the solution of the ODE will be u is equal to c1 plus c2 cos 2t plus c3 sin 2t, will get it. So now I want a solution in terms of partial differential equation, replacing c1, c2, c3 in terms of other variable. So I'm going to represent it in terms of x variable. That is, the solution of PDE will be now u is equal to f of x plus g of x cos 2t plus h of x sin 2t. So now I want the value of dou u by dou t, dou square u by dou t square to use the initial conditions. So I'm going to differentiate this equation with respect to t. So I will get minus 2 f of x will become 0 since it is a constant here, minus 2 times of g of x sine 2t plus 2 times of h of x cos 2t. I will get it. Differentiating this equation again with respect to t, I will get dou square u by dou t square is equal to minus 4gx cos 2t minus 4hx sine 2t. So since the given initial conditions are u is equal to 0, dou u by dou t is equal to 0, dou square u by dou t square is equal to 4 when t is equal to 0. So first I am going to replace u is equal to 0, t is equal to 0 in this equation. So if I replace that condition, I will get f of x plus g of x is equal to 0. I will get it. Again, if I replace dou u by dou t is equal to 0, t is equal to 0, I will get h of x is equal to 0. Again, I am going to use a condition dou square u by dou t square is equal to 4 and t is equal to 0. So I will get a g of x is equal to minus 1. I will get it. So from this condition, we can estimate the value of f of x as plus 1. So right, like if I replace the condition, first condition, I'll get f of x plus g of x will be equal to 0, as I told that. Again, from the second condition, we'll get h of x is equal to 0. From third condition, I'm getting g of x is equal to minus 1. So from this condition, I can estimate the value of f of x from this equation. So f of x will be equal to 1. So on replacing all this condition in the previous equation, so I will get u is equal to 1 minus cos 2t, and 1 minus cos 2t will be 2 sine square t. So these are required solution for the given partial differential equation. Thank you.